All right, today we are going to start into section 3.5, solving two-step equations. We're going to kind of break it down into two parts, kind of the basic two-step equations, and then we'll add a little bit of difficulty as we go. Okay, this is, like I said, a very important concept to understand. It's a very important concept to master. So please make sure that you are trying the problems. Make sure you know how to do these problems, which means that you're writing them down, you're trying them, and you're checking your solutions. You're not just going right to the solution page and writing them down. Right? Make sure you know how to do these. It'll make next year's algebra class so much easier if you're gaining an understanding of how to solve equations, right? Because it just builds from here. All right. So let's start learning targets to solve two-step equation. And a two-step equation is a equation that contains two operations, right? So we looked before at using just one step to solve. For example, if it was a variable plus a number, we use subtraction to solve. If it was a variable times a number, we use division to solve. And so we looked at just one operation and then we had our solution. Today we're going to look at multiple steps in order to solve our equation. Okay, again, we'll use inverse operations to solve, and we're going to use the reverse order of operations, meaning we have to get rid of addition and subtraction first before we get rid of or before we inverse multiplication and division. And that'll make more sense as we look at the examples. All right, and then remember, when we're trying to solve, we're trying to isolate the variable, meaning get it by itself on one side of the equation. All right, so let's look at some examples, right? First off, if I look at number 1, I'm reading that 5x minus 2 equals 13. Right? If we were to describe this problem, right, we would say 5 times a number, right? And we'll just call that x. So 5 times x minus 2 equals 13, right? So we have two operations. We have the subtraction and we have the multiplication, right? So we want to inverse these operations. So I inverse subtraction, remember, with addition, and I inverse multiplication with division, right? We have to work backwards to get to our variable. So let me get this out of the way real quick. All right, as always, we want to separate the left and the right side of the equation, because remember, in order to keep things equal, we have to do the same thing to both sides of the equation. So if I look, here is my variable term, right? The 5 times x. And then I have this constant out here, this minus 2 or negative 2, right? In the end, remember, we want to isolate. I want to get x by itself over here, and then it's going to equal some number. We have to figure out what that is, right? And one way to do that is I could just guess, right? I could say, let's say that x is 2. Okay, let's plug in a 2 here. 5 times 2 is 10, minus 2 is 8. I can see that that does not equal 13. All right, it's too small. So I could go on to the next one. I could try a 3. Right? I could say 5 times 3 is 15. 15 minus 2 is 13. So I should know that my answer is going to be 3, but let's see how we get there besides just guessing a number and checking to see if it works. So here's my variable term. The first thing I want to get rid of or inverse is this negative 2. I wanted to get it to cancel out. I want it to equal 0. So the inverse of minus 2 is to plus 2 on both sides. So when we do that, negative 2 plus 2 is 0. So we're left with 5 times a number is equal to 15. And so then this is a multiplication problem over here. So to inverse that, I would divide both sides by 5. Right? So that would be 1x, right? That's what I wanted, to isolate it down to 1x. And 15 divided by 5 is 3. right? And remember to check that. I would just simply substitute that value, right? 5 times 3 minus 2, does that equal 13? And yes, it does. So 3 is my solution to that equation. All right. Looking at number 2, right? We have here, right? If I'm going to say this, it's 4 is equal to some number divided by 6, right? And then plus 11. So if I think, right, my two operations is addition, right, plus, and division. So I should know going into this that my inverse operations are going to be subtraction and multiplication, right? To get rid of a plus, I subtract. To get rid of divide, I multiply. So here's my variable term. The first thing I want to do is get rid of or inverse the number, the constant, which is positive 11, right? The sign in front goes with it. So if I wanted to cancel this out or inverse it, I would subtract 11 from both sides, right? So positive 11 minus 11 is 0. So then I have n divided by 6. Now over here, 4 and negative 11, right? And I know, remember our integer rules, right? I gave you that sheet on the last few agendas. So if you need that, go back and get it, right? But we have opposite signs. So I'm going to subtract the values, right? So I can do 11 minus 4. And I know that that should give me 7, okay? Now, going back to this original, which value is larger? I can see that the negative 11 is larger in value, right? So the negative is going to carry the weight for that problem. So it should be negative 7 there. Now, to solve for n, right, I still have to get rid of this divide by 6. And we do that through multiplication, right? 6 over 6 is really just 1. So that would leave me with 1n. And over here, I have to do the same thing because I can't just multiply one side. Times by 6, we get negative 42, right? Our integer rules tell us a negative times a positive should result in a negative value. So we get this as our solution, right? And notice the answer key will probably be written as n equals negative 42. Okay, if two things are equal, it doesn't matter the order. You can just flip-flop sides there. So quick check of that. So I'm going to type in negative 42 here. Negative 42 divided by 6 is negative 7. Negative 7 plus 11 is 4. So that checks out. That is my solution. All right. I'd like you to take a minute and solve number 3 and 4. So pause the video here, and we'll come back and check in just a minute. All right, so let's look and see how you did here. So we want to separate, right? So here's my variable term, right? So I want to inverse this minus 4, right? To inverse this minus 4, we do that with a plus 4. We need that on both sides. So negative 4, positive 4 cancels. So over here we have negative 2 times some number. And if we look here, we have negative 10, positive 4. So opposite signs, right? So we can subtract. I know there's a difference of 6. The negative is a bigger value, so it will carry to be a negative. Now, negative 2 times something has to equal negative 6. Hopefully you can see that it should be 3, but let's do the inverse, right? The inverse of multiplication is division. So I'm going to divide by negative 2, right? That gives me 1, right? Negative 2 divided by negative 2 is 1, so that isolates that to 1x. Got to divide this side by negative 2, right? Remember, two negatives, look at your integer rule chart. Two negatives in division equals a positive 3. right? Again, get used to checking your answer. So we would say, does -2 plug in our solution of 3 minus 4? So -2 times 3 is -6 minus 4. Does that equal -10? And that checks. All right, number 4. Okay, going into this problem, I see I have a division and an addition. So I'm going to be using subtraction and multiplication to inverse those. So here's my variable term, t divided by 4. So I want to start over here, get rid of the number, okay, which is +7. So I would inverse that with -7. So we have t divided by 4, right? That was 0. Now, addition of the same, right? So, sorry, excuse me. We have -3 and -7. So they're the same sign, which means I'm going to add, since they're both negative, right? It was keep that negative value, right? That's with addition. Don't get that confused with multiplication and division. All right, it's probably a good thing to have your integer rules sheet out with you as you do this, just as a reminder, or use your calculator to check, okay, as you continue to work with learning and understanding those rules. So now we have number divided by 4 equals -10. Okay, so the inverse of division is multiplication, right? And again, 4 divided by 4, right, equals 1t. That's what I'm trying to do, is isolate. And I have to multiply this side by 4. So -10 times 4 is -40. Okay. Again, plug that in. -40 divided by 4 is -10 plus 7. Yep, that equals -3. That is my solution. Okay. We're going to do this assignment a little bit differently. All right. I'd like you to go to your books. Okay. And you are going to work on just part 1. So you're going to pause the video here and you're going to work on just part 1 of the assignment. Okay. Now, when you go to your answer key, all of the answers are together, but you're just going to go do part 1, check your work, make sure that you're understanding these two-step equations before we move into an extension of these. All right, so pause the video here and work on just part 1. Okay, when you're finished, you can come back and watch the second half of the video. All right, hope everyone did well on that part 1 of the assignment. Okay, we're going to continue on here looking at our two-step equations and solving for negative coefficients, because a lot of times when we solve these, the signs just kind of disappear for some reason. So if we look to solve, all right, first of all, if there's not a coefficient there, right, it's really understood to be a 1. So this would be 4 minus 1x. All right, so even though they don't write it here, I know that this is a +4. So if I'm going to isolate my variable term, I got to get rid of the numbers first. So here's a +4. Right? We should inverse that with a -4 or -4, right? Because that would equal 0. Now this is important. So I have to drop this sign with it. So we have -1 times x. And over here we have 10 minus 4, which is 6, right? Stays positive because the 10 is bigger, and that's positive. Now, this is really not isolated because it's -1x, right? Or think of that as opposite of x. So in order to get rid of this multiplication here, we have to divide by -1, right? And that cancels there. We would end up with x equals -6. Notice that dividing by a -1 just changes the sign or changes the value on my solution. Again, you can go check this out. Okay, so if I were to plug that in, I'd have 4 minus -6, right? Because I have to plug that in for x. Does that equal 10? Answer's yep, so that checks out to be here. See if you can go through and solve 2, 3, and 4 using that method. All right, pause here. I'll see you in a minute. All right, let's see here. So if I separate, all right, notice my variable is on the right side. Right? So here's my variable term, right? Really negative 1t. So this is a positive 4. So I'm going to start with subtracting 4 from each side. Right, that would cancel. So dividing by negative 1, I get t equals negative 4. Here, variables on the left side of the equation. So again, I want to isolate it over here. So now I got this negative 7, right? To inverse that, I'd have to do plus 7. So that would cancel. I have negative 1y equals 11, right? Divide out that negative 1, and we get y equals negative 11. All right, gotta be careful on number 4 because we're going to be dealing with two negatives going in. So here's my variable term. So I got to get rid of this number, right? Since it's a negative 1, I'm going to go plus 1. Cancels. So we have negative 1z. And over here, got to be careful. Negative 5 plus 1. Negative 5 positive 1. Those are opposite signs. So I'm going to subtract. Right? 5 minus 1 is 4 since the negative is bigger. Oops, let me clean that up a little bit. We should get negative 4. So finishing here, I got to divide out that negative, right? Divide out that negative 1. Cancels, so I'm isolating z. Negative 4 divided by negative 1, if you look at your integer rules, dividing two negatives ends up as a positive 4. Right? Double check that so we can go negative 5. Does that equal negative 1 minus 4? Answer is yes. All right, so one other type. So if you look at these ones, it says simplify before solving, right? Meaning, if you remember back to section 3.2, we had to simplify by either distributing to get rid of parentheses or just by combining like terms. So we're going to do the same thing here, and you'll notice that there's multiple variable terms in the problem. So we want to first clean that up by combining like terms, right? Again, if there's no coefficient, it's just a 1. So I can see here on the left side, I have two variable terms, and I want to combine them into 1. So I have a 1 and a minus 5. So if I combine that, that's negative 4m, right? I still have plus 3. So I have a variable term and a number term, okay? So now I'm ready to do my two-step equation. So here's my variable. I have to get rid of the number term first. So what would I do to get rid of a positive 3? Do minus 3. So I have negative 4 times m, that cancels, equals 47 minus 3 is 44. The inverse of multiplication is division. So I'm going to divide by negative 4. That cancels. 44 divided by negative 4. I should end up with m equals negative 11. Let's try number 2. Okay, again, so if I look, I got two of these variable terms over here. So the first thing I want to do is combine them. Right? Notice that this is just the number 5, so I'm not doing anything with that. There's no other numbers on this side. So I have 2x, 3x, give me 5x, right? So I've combined those into one term. So I have that plus 5, and I still have the 25. So now I have my variable term and my number equals 25. So I want to get rid of a positive 5. So we can subtract. So we'd have 5x. 5 minus 5 is 0. 25 minus 5 is 20. Here, the inverse of multiplication is division, right? So that would cancel out and give me 1x. Got to do the same thing to the other side. So I end up with x equals 4. Right? Again, you can go back and plug these in and check your answer. Right? So here I'd have 2 times 4 plus 5 plus 3 times 4. I'm asking, does that equal 25? So 2 times 4 is 8. 3 times 4 is 12. So you got 8 and 5 is 13. Plus 12 is 25. That checks out. All right. Take a minute and solve number 3 and 4, right? Remember, you got to combine like terms first and then solve. So pause here and I'll see you back in a minute. All right. So looking at number 3, notice there's only 2 terms over here. So we have 2w and negative 4w. Right? So those are like terms. If we combine them together, 2 minus 4 should be negative 2. All right. Now notice I don't have a number term. It's really a 0 already, right? Negative 2w plus 0. So there's nothing I have to do with that number term. I just have to inverse this multiplication here. So we do that through division. Divide both sides. So here we get 1w. On this side we get positive 5. Right? So w should equal positive 5. Over here, my like terms are negative 3y and positive, remember that's a 1y. So those are my like terms. So I should have 1 minus 2y equals 5. So again, here's my variable term. So I want to get rid of this number, which is a positive 1. So the inverse of plus 1 is minus 1. So positive and negative 1 cancel out. We have negative 2 times y equals 4. The inverse of, here I'm going to rewrite that. We have negative 2y equals 4. So the inverse of multiplication is division. So I'm going to divide both sides by negative 2. That would leave me with 1y. 4 divided by negative 2, right? Use your integer rules. It should equal negative 2. Again, some of these are getting to be more complex, all right, just to challenge you as you continue to understand these. If you have questions along the way, make sure you ask, all right? And I'd like you now to go on to part 2 and work on these problems from section 3.5, and again, use the answer key to check your work. If you have questions, feel free to shoot me an email. Hope you have a great day.